Hi, I'm Costa. I am the founder of Netdata. How many here use a log management solution? Any? Okay. How many are familiar with systemd journal? Oh, more. Okay, that's great. So, guys, we were building at Netdata, we were building a log management solution ourselves. So, Netdata had only metrics up to last year. So, we wanted to also to enter the logs arena and do it in a distributed way, the way we do it in Netdata. So, instead of centralizing the logs, this is what we do for metrics too. So, instead of centralizing the logs, to distribute the code. That was the idea, and this is the idea for metrics too. So we had built our own. We had an open source, a log management solution. It's in GitHub. And then I realized what systemd journal is. And I was really impressed. So at the end, we dropped our own project. And we said, OK, let's help systemd journal be ready for prime time. And this is what we do. So this slide is probably going to be a little bit strange for a few people, especially the ones that are familiar with Loki and Elasticsearch. So let's see how these log management solutions work. The first is the indexing strategy. So what do they index? Loki has a stream philosophy. So there are some labels, and based on the label values, it creates a stream. Think of it like a text file. Of course, it's indexed and it's binary and it's compressed, but think of it like for all logs that have a fixed set of labels, same values on all logs, put them in one place. That's a stream, okay? So what it indexes is just the labels. And as the cardinality of these labels increases, actually the resources required by Loki get tremendous. After some time, after some cardinality, you need a lot of memory, a lot of CPU, etc. Elasticsearch has a different philosophy. So it indexes tokens. So it takes the log, splits it into words, and indexes everything. Amazing. So you can search for whatever you want, and it's indexed, it's fast. Systemd journal indexes fields, the keys. So it considers that for systemd journal, a log entry is a series of name-value, key-value pairs, a lot of them. And each log entry can have any number of key-value pairs, any number of keys, any number of values. So they don't have to be homogeneous or something. Every log entry, a completely different story. What it indexes is every key, every value, and every combination, key-value pair. Okay? So if you want to find all the logs that have A equals B, it's like that, immediately. If you want to search for something inside the value, part of the value, full text search. It has to traverse everything. So this is the weakness, let's say. But the key things that it has is that it offers some advantages, let's say, over the others. The first is in scalability. All of them are horizontal. So all of them, you can have one big machine or a lot of machines ingesting the logs, etc. Different strategies, of course. Loki has ingesters and distributors. Elastic has sharding and replication. Systemd journal, to scale across machines, it needs a shared storage. Ingestion efficiency, and this is, I think, the key benefit of systemd journal. You see that for Loki, this is 5,000 to 10,000 entries per core. Now, let me explain this, because this may sound wrong for some people. All systems can scale to anything. This is an indication of how much resources they need in order to do it. So all of them can, even if you have 1 million entries per second, all of them can do it. But what resources do they need? So for Loki, you should expect about 5 to 10,000 entries, log entries per second per core. For Elastic, 2 to 5, because it's a lot more complex, the indexing. For systemd journal, it's 25 to 50,000 log entries per second per core. Storage efficiency, another critical factor. Loki is the most efficient. Why is the most efficient? So if you have 1 gigabyte of uncompressed logs, Loki is going to need about 250 megabytes of storage. A gigabyte uncompressed, 250 megabytes Loki. How it does this? It does it because the logs are just a time series. They don't index much, anything actually. It's just some labels outside the logs themselves that have marked the logs. So it's just like a text file. If you zip it, if you gzip it, it's going to be 25%. At the end, it's going to be 25% of the original size. For Elasticsearch, mainly because it has a lot of indexing and stuff to do, the storage skyrockets. It starts at 300%. So if you have 1 gigabyte of logs uncompressed, Elasticsearch is going to need 3 gigabytes plus. Depends on the indexes, etc. For systemd journal now, since it indexes a lot of stuff, on an uncompressed file system, it needs 2 gigabytes. So 1 gigabyte, the source, 2 gigabytes. But if you put it in a compressed file system, it goes down to 500 megabytes, so half the original. So it's in the middle. And for importing, you have for Loki, Promptail, FluentB actually works everywhere, but for systemd journal, this log to journal is our tool. It's an open source tool that allows you to scrape any kind of logs, if it is JSON, log format, or even whatever it is. You can provide regular expression patterns to extract the fields and make it structured. Now, the interesting part is the query server. Systemd journal does not need anything. So there is no server. Systemd journal D is an ingester. That's a job. Give me logs, let me put them on the files. To query these files, nothing is needed. So all journalctl, for example, at Netdata that presents these dashboards for systemd journal, just opens the files. Now, and about the dashboard, Netdata fills the gap there and provides this missing part. So what are they good for? What are the key strengths and the key weaknesses? Loki, very small disk footprint, good performance. The key weakness is the limited indexing. So you rely on the front end actually to do a lot of work to analyze the logs. Elasticsearch, full text indexing, full capability about searching and indexing in your logs, but it comes at a cost. Complex, heavy, extreme storage footprint. Systemd journal is in the middle again. It's a simple, fast, no need for some server or something, low resource usage. The key weakness today is that we have not yet, as Netdata, added alerting to it. This is for our plans for this year. Now let's see a little bit how this works, how systemd journal works. As I said, systemd journal is a number, is just a collection. Every message in systemd journal is a collection of key value pairs. That's it. Priority equals this, syslog of facilities equals that, code file, code line. Now the keys are not fixed. Systemd journal suggests 20, 30 fields, but you can put as many as you want, your own, do whatever you want. There is no manifest, there is no schema. You just put all the fields with any values you want and it will do it. There are only some very small limitations on the keys, like that they are all capitals and the only symbol is underscore, that's allowed. Now, with journalctl on all Linux systems, you can use journalctl fields to actually see all the fields that are there across all the logs that you have. You can do journalctl with a field equals a name of the field, and it will show you all the possible values this field can get. And of course, you can query for logs based on field combinations, specific values for specific keys. Now, systemd journal has been designed in order to be highly available. So the first thing is that it has persistent storage. It will log everything to varlog journal, create files there, etc. But if, for any reason, the system does not have the disk, so if you unplug the disk while the system is running, you unplug the disk, what the systemd journal will do, it will start logging to run directory, to MPFS, so that you will not lose anything. It has a rate limiting capability, so if someone starts bombarding the system with the same log again and again and again, it will filter it out. And it handles also rotation by itself. So you don't need to care. You can say that you want some certain size or certain days, or even some disk-free space. Use all the disks, give me this free at any given time. The format of journal files, and that's the magic of systemd journal, is that it is an append-only format. So it creates journal files and always appends data to it, and it never overwrites data at the beginning of the file. It has a chain splitting philosophy where there are chains, extents, let's say, of data that it writes, and all these are signed with, are verified with signatures to actually, with hashes to actually detect corruption. It has checksums for integrity, and a unique feature of systemd journal is that it supports forward secure sealing. This means that it signs the actual logs that are saved to disk, and if a change is made on the binary files, then it can detect it. This makes it ideal for compliance, since you know that even you cannot change, cannot alter a log entry. No one actually can. Or to be precise, you can alter it, but it will detect it. Now, journalt, as I said, is an ingester. It doesn't do anything else, just receive logs, put it on disk. The files are memory mapped files. This is why they are so fast, and this means also that the available memory on the system, the buffers, the cache of the system is used to speed up queries on these memory mapped files. This is why there is no need for a server. The free memory of the system is used for cache for these files. It has a high concurrency, so on each journal file there can be one writer and multiple readers at the same time. So one thread is writing logs and a lot of others are reading logs at the same time. And systemd journal, and actually libsystemd, has the ability, when you have a ton of journal files, to query them at once. So it doesn't matter if they come from the same server, from different servers, from different namespaces, from different services, it doesn't matter. Journal files can be merged, let's say, on the fly, so that you do one query and you get all the logs across all the files. Now, in order to have centralization points, so how do we centralize the logs? We have, I don't know, 1,000 servers. How do we centralize the logs? So systemd journal comes with the following tools. One is systemd journal upload. You run this to send the local journals to a central place. And then there is systemd journal remote, which is the receiver. This thing sits there, listens on a port, accepts connections from systemd journal upload, and stores the data to files. This way, you can actually move your logs around, or build one or multiple centralization points within your infrastructure. It is important that when you use journal.ctl or even Netdata for the front end, and you have files, journal files from multiple nodes, both tools unify the output. So you are going to have a response or a page in the data, or response from journal.ctl that has all the nodes. This line comes from this node, that line comes from the other node, etc., etc. This is, we use for this the ability of journal to actually merge everything. So, systemd journal already receives data like this. Notice that here, where is JSON? No JSON. Log format. No log format. So, how we improved it? This is the pipeline. The colored stuff is Netdata additions. So the other flows work by systemd with systemd journal tools only. So the idea is that you have applications, they write either to the journal API or syslog or whatever, they send up to the journal, or they write to log files. If they write to log files, nginx, HA proxy, whatever it is, that generates log files. Then you can use log to journal to actually convert the structured log entries into structured journal entries and ingest them. And then you can use Netdata to actually have the dashboard, the Kibana, Grafana-like dashboard that you need. We identified a few problems with systemd journal, so we submitted some patches to improve its performance 14 times when querying. And also, we managed, so the Netdata plugin that does this work actually manages to overcome the speed limitation, let's say, even on older systems. So if you have a CentOS or something old that doesn't have a modern libsystemd in it, still our UI is fast enough. Log to journal actually is the equivalent of promtail or filebit. This is how you should think about it. It tails logs, extracts information from the logs, rename fields, rewrite values, all this processing, and then export this to systemd journal. We have a tool also that we call it systemd cat native. This accepts native structure messages for systemd journal and can send them either to the local journal.d or a remote systemd journal remote. Now, we have an explorer. I am running out of time, so I'm going to speed up a bit. We have an explorer. It looks like this. It's the standard thing, a histogram, some fields with values, counters, etc. There is full text search in it. It's very fast, as you see on that view. There are 15.6 million entries, log entries in just this view. It's fast. Actually, it's a lot faster compared to anything else, and mainly because we start sampling, and a lot more accurate than anything else, mainly because we start sampling at 1 million entries. So if you use Kibana or Grafana with log, etc., you are going to see that they give you percentages about how frequent is this field or that field, or it's this value or that value. And these percentages that they give you are based on the last 5,000 or 20,000 entries, something like this. In the case of Netdata, we always start sampling after 1 million entries. I skip this. This is just a few things that we did. Netdata is distributed monitoring, so we managed to route requests through a Netdata network to reach the point where the logs are. So if you want, you can keep the logs at the edge, not centralize it, and the data will still figure it out. And this is a use case that we did a few days ago. These guys had, unfortunately, I can't mention their name, but these guys did, they had 1.8 billion transactions a day and a microservice setup of 8 steps, each one logging. And we managed to minimize, let's say, the logs monitoring infrastructure. It was 40% of their cost, of their operational expenses, was because of logging. And we just did it 5% with systemd journal. And just a slide about Netdata, a popular project, 1.5 million downloads a day. Done. Thank you very much, guys.